To be honored, I stay here, and today I would like to present our work about the structure-based study of thiazole, coumarin, and Azomethine derivative as diol, TGF-beta receptor 1 and TLR4 modulators, a mechanistically integrated antifibrotic and immunoregulatory strategy for post-transplant hepatic graft preservation. And I have no CRA to disclose, and this is the background. The liver transplantation restore survival, yet the late graft failure remains common due to chronic immune-mediated injury and fibrosis. And the clinical drivers, fibrosis HSC activated via TGF-beta receptor 1, excessive ECM deposition, architectural distortion, and progressive graft dysfunction. Immune dysregulation, introduction and TLR4 on Kupffer cell, TNF alpha and interleukin 1, beta and interleukin 6 cascade sustained inflammation and tissue injury. Therapeutic gap standard immunosuppression curbs rejection but does not reliably halt long-term fibrogenesis. And this is we center on post-transplant hepatic injury where fibrosis and immune activation intertwine. Pathway roles, TGF-beta receptor 1 activation, fibrogenesis, activated hepatic stellate cell HSC, extracellular matrix ECM protein, drives scar formation and progressive graft dysfunction, and TLR4 activation, innate immune dysregulation triggered by introduction and LPS binding to TLR4 on Kupffer cell, and activate NF nuclear beta and increase TNF alpha, interleukin 1 beta, and interleukin 6. Cross-talk between TGF-beta receptor 1 and TLR4. TLR4 signaling enhance TGF-beta expression and accelerating fibrogenesis, and TGF-beta promote immune tolerance, yet paradoxically fuel chronic fibrotic load. And for this method, I would like to deliver in medicinal chemistry. I have two target protein TGF-beta and TLR4 and the ligand, and system preparation and the docking calculation and optimization. And then the candidate of the ligand and the target protein, we run docking. Before docking, we have to validation of the RMSD scoring. And then after the result of the docking, we have to analysis of the ADMET profiling, absorption, distribution, metabolism, excretion, and toxicity using PKCSM and Swiss ADMET server. And this is the result of the figure 1 is chemical structure of 6,1. The ternary thiazole, coumarin, Azomethine derivative have a stronger dual binding TGF-beta receptor 1 minus 11 kilocalorie more and TLR4 around minus 8.6 kilocalorie more. And otherwise, the compound 6K favorable multi-target and pharmacokinetics. And this is what the 3D and 2D visualization of the binding interaction between the ligand and the receptor. The first is docking interaction of 6I with TLR4. The docking pose of the 6I in TLR binding pocket, hydrogen bond with key residue with the arginine 264, asparagine 294, ISN 268, and glutathione 266 is strong and choring. And the PKation and the hydrophobic contact with the lysine 362, tyrosine 292, and leucine 60, the stabilized complex. The highlight the stable occupancy and broad interaction profile such as 6I as strong binder to TLR4. And the next is the docking interaction of 6,1 with the TGF-beta receptor 1. This is the 3D and 2D interaction. Docking pose in 6,1 with TGF-beta receptor 1. Hydrogen bond, this is have a one hydrogen bond with the lysine 337 and the critical stabilization of the ligand. And the other one is the hydrophobic interaction with alanine, valine, leucine, and tyrosine reinforce binding within the hydrophobic cavity. And the highlight robust multi-point interaction explain strongest binding energy around minus 11 kilocalorie more. These are for 6R to TGF beta. And this is for the pharmacokinetic. The physical property, the slug P is around 6.81 moderate lipophilicity and poor solubility, and the log S is around minus 3.33 to minus 0.270 log molecular, poor moderate solubility. And the pharmacokinetic, the absorption is excellent, the PP permeability low, causing the liver focus distribution, the clearance moderate, favorable pharmacokinetic, and for CYP1A2 no inhibition, minimal interaction risk, and drug likeness is good, and the toxicity is moderate, oral LD50 around 2.61 and acceptable predicted safety profile. But we concern in 2 points the physicochemical properties about the solubility and the toxicity. We predict using the beta cyclodextrin. Beta cyclodextrin, well known in industry pharmacy, the glucose derivative, the encapsulate to enhance bioavailability and the reduce toxicity and enhance the solubility. This is for the modeling of the inclusion complex with beta-cyclodextrin. The beta-cyclodextrin improve the aqueous solubility and dissolution rate, enhance bioavailability, enable liver target delivery, and the potential to reduce toxicity and control pace with binding energy minus 7.4 kilocalorie more and 7H bonding. The conclusion, Thiazole, the Coumarin Azomethine derivative, show dual inhibition of TGF-beta and TLR4 with favorable pharmacokinetic and safety. And the limitation, this is just the preliminary of the research in silico only, biological validation pending, and solubility challenge high log P. Future outlook is in vitro, in vivo cell line, and validation on antifibrotic and immunoregulatory activity, and toward clinical translation for long-term graft survival. Thank you.